Hello, this is Mrs. Huntley. This is video 1 on the Pythagorean theorem. We are stepping out of the Eureka materials just for a week or so to go into some supplemental materials on the Pythagorean theorem. And this first page of your packet is what's called doodle notes. And you're going to need colors for this. You're going to need colors for part of the lesson, and you're going to need colors to decorate your page because that's what makes doodle notes fun. So, what is the Pythagorean theorem? The Pythagorean theorem is for finding the length of a missing side of a right triangle. So we're only going to be looking at right triangles for the next week or so. And a right triangle, of course, has one right angle in it. So one 90-degree angle. It's shown by having a little box in the corner, like here. So that is my right angle of this particular triangle. Now, Pythagoras was a Greek mathematician, and he discovered that if you have a right triangle, it has some special properties. And the special properties are if you take the length of the two shorter sides of the triangle and square them, it equals the length of the largest side of the triangle squared. So let me back up. Oops, that's not what I wanted. Let me fix that. So I thought I had a pen. I did have a pen, it just didn't change. Okay, so a squared plus b squared equals c squared. You've probably seen that, and you maybe even have had some lessons on that, but maybe not in as much detail and depth as we're going to go into here. So what does that mean? If this is the a side of my triangle, it is 3 units long. Here's 1, 2, 3. So it's 3 units long if I'm just looking at this part of my right triangle. And that's my A side. We'll call this A. And B is over here, and B is 4 units long. So again, if I'm only looking at this length, I've got 1, 2, 3, 4. So that's 4 units long. Looking at my C side, I've got, and we'll call this C, 5 units long. Okay, so I've got my right triangle. The C side is across from my right angle. Now what Pythagoras discovered is if you take the A side, the length of the A side, and square it. Now remember that when you square something, you're multiplying it by itself. So we're going to take 3 times 3, and that is going to equal 9. So this, oops, come on now. Why are you not switching over for me? I want a blue highlighter. There we go. So if I take the length of my A side and I square it, I'm going to get 9 units. So I'm just going to color this whole thing in blue. And if I take the length of my B side and square it, so 4 squared, 4 times 4 is going to be 16. I'm going to have 16 units on this side. And Pythagoras says that's going to equal my C side square. So let's see if that works. What I'm going to do is I'm going to color in 16 of the C side green. So that's my B side taking up that space. And then the remainder, I'm going to see if I've got 9 of them, and that's going to represent my A side. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. So Pythagoras was right. The length of my A side, which is 3 squared, is 9. 9. Let's go back to a pen here. Come on now. So this is 9. This is 16. This is 25. 9 plus 16 does equal 25, and you can see it there in green and blue. So, next thing. let's go ahead and label up this right triangle, just so we know what we're talking about when we're talking about the different sides, because I've been using words like leg and hypotenuse, and you may not know what that means. So the legs are the short sides of the right triangle. They're the A and the B side of the equation. They're interchangeable. It doesn't matter if I label this one on the bottom here. Oopsie, that's not what I meant to do. If I label that as A or the other one as A. So these guys are interchangeable. I could call the longer one B and the shorter one A. Does not matter. A plus B is going to be the same thing as B plus A. The one that matters and the one that you always have to be able to pick out is the hypotenuse. The hypotenuse is the longest side of the right triangle. It's always located across from the right angle. So what I tend to do in order to remember that is I draw an arrow from my right angle to the opposite side so that I remember that that's my special hypotenuse side. Again, it doesn't matter whether I call the longer leg A and the shorter leg B, as long as the longest side is being labeled with a C. So let's take a look at this example 1 here. A right isosceles triangle has legs 6 meters long each. Find the length of the hypotenuse to the nearest tenth of a meter. Okay, so I've got isosceles means my two legs are the same size. So if I use my a squared plus b squared equals c squared, if you want to draw a picture of it, you may. So if I've got my right triangle and my two legs are going to be both 6, 6, here's my right angle, and that's going to be my c side, I'm going to go ahead and fill in my unknowns in my equation. So instead of a squared, I'm going to say 6 squared plus b squared, I'm going to say 6 squared again, equals, I don't know the length of the c side, that's what I'm trying to figure out, equals c squared. So 6 squared, 6 times 6 is 36. So 36 plus 36 equals c squared. So if you don't know these off the top of your head, you're going to want to start memorizing squares and square roots, but you can use a calculator, so don't panic about that. 36 plus 36 is 72, so 72 equals c squared, which is awesome. If I had this big drawing, I would know that the c side would be a great big square of 72 boxes in it. But I don't want c squared. I actually want c. So what I'm going to do in order to undo a square is I'm going to take the square root of both sides. So if I take the square root of c and the square root of 72, because again, whatever I do to one side of the equation, I have to do to the other. When I take the square root of a variable that's been squared, what it does is it knocks off the square. So c squared, the square root of c squared is c. And the square root of 72, when I plug that into my calculator, I get 8.485, and it goes on. If I'm rounding to a tenth of a meter, I'm going to round to the first spot past the decimal, and I look here, and that's greater than 5, so I'm going to say my answer is 8.5 meters. The 4 goes up 1 because the number next to it is greater than 5. So that would be my answer on this one. Example 2, I don't know one of the legs. So again, a squared plus b squared equals c squared. Plug in what I don't know, or what I know. A squared is x. I don't know that if this is a and this is b and this is c. So I'm going to have x squared plus 8 squared equals 13 squared. X squared plus 64 equals 169. Now to get my x all by itself, I'm going to subtract 64 from both sides of the equation. And I'm going to be left, I'm going to draw it up here, with x squared equals 105. But again, I don't want x squared, so I'm going to take the square root of x squared and the square root of 105, and I'll have x equals 10.248, it looks like. So if I'm rounding this to the nearest tenth, again, this number is less than 5, so I'm going to leave it at 10.2 feet. Okay, I hope that this makes sense. So using the Pythagorean theorem, a squared plus b squared equals c squared, and this is where you can get your colors out and just kind of decorate that in. Here's what each letter represents. A and B represent the lengths of the legs. C represents the length of the hypotenuse. And I'm going to move that so that it's on the next line. Okay, C represents the length of the hypotenuse. And again, the word hypotenuse is one you're going to have to commit to memory and make sure you understand what it means. Next page, finding the missing length. Okay, we're going to take those notes in a minute. Hang on. Okay, finding the missing length. So our Pythagorean theorem states a squared plus b squared equals c squared. We've got two sides here and we're missing the hypotenuse. So let's go ahead and plug in what we know. If you're comfortable at this point, you can go ahead and pause the video and see if you can work these out and then come back and see if they're correct. So if this is A, this is B, and this is C, I'm going to say 5 squared plus 12 squared equals c squared. 5 times 5 is 25. 12 times 12 is 144. Grab your calculator and do 25 plus 144. I thought I had this worked out and I do not. Is 169. Take the square root of 169, and that's 13. So the C side of this triangle is 13. I should have recognized that because this is something called a Pythagorean triple. When the C side is a whole number, that's called a Pythagorean triple. So this would be a 5, 12, 13 Pythagorean triple. We'll talk about that more in class. The next example. If this is my A side, my B side, and my C side, I'm missing my B side here. I don't know what that is. Well, I shouldn't have crossed it out like that, but I just don't know what that number is. So A squared, instead of A, I'm going to say 9 squared plus B squared equals 16 squared. 9 squared is 81 plus B squared equals 256. I'm going to subtract 81 from both sides. B squared equals 175. I don't want B squared, I want the square root of B squared, so I'm going to square root both sides, and the square root of 175 is 13.228, and it goes on. I'm going to round to the nearest tenth, and I'm going to say it is 13.228, or about 13.2. Okay, here's some notes. The Pythagorean theorem, a squared plus b squared equals c squared. It's used to determine the missing side length of a right triangle and used to determine if a triangle is a right triangle. The necessary vocabulary that you've got to have: legs, the short sides of the right triangle, the legs are on both sides of the right triangle, and the hypotenuse is the longest side of the right triangle. It's always across from the right angle. Squaring a number is a number raised to the second power, so that's like the number times itself. Okay, moving right along. How can I use the Pythagorean theorem to see if a triangle is a right triangle? So you should have the A and B measures of the legs, or the sides of a triangle, and C is the measure of the hypotenuse. And c squared is equal to a squared plus b squared. Then the triangle is a right triangle. If it's not equal, then it's not a right triangle. So this is for an instance when you have all three sides, and notice we don't have that little square in the corner. So we don't know if this is a right triangle or not. So we need to set it up. Is 3 squared plus 4 squared equal to 5 squared? Let's see, 3 squared is 9, 4 squared is 16, 5 squared is 25. Is 9 plus 16 equal to 25? Let's see, 9 plus 16 is 25, and 25 is equal to 25, so that one works. In other words, you can check to see if a triangle is a right triangle by seeing if the Pythagorean theorem is true. Use the Pythagorean theorem. If the final equation is true, then the triangle is a right triangle. If the final equation is not true, then the triangle is not a right triangle. Now keep in mind, this looks like a right triangle, but it would be very hard for us to discern whether or not this is, 89 degrees, 90 degrees, 91 degrees. It's very hard to just eyeball it and look at it and determine whether it's true. We need to use our math to prove that it's true or it's not true. Okay, so is it a right triangle? If I know that one side is 8 inches, one side is 17 inches, and one side is 15 inches, is it a right triangle? I don't know. I've got to use the equation to figure it out. The first and most important thing to figure out when you just have numbers like this and it's not labeled in the drawing is which one is the hypotenuse, because that's the one that mattered where I put it. Remember I said the hypotenuse is always the longest side. So in this instance, which is the greatest number? And 17 is got to be my c side. Okay, so my equation, a squared plus b squared equals c squared. This has got to be my a, this has got to be my b. Or I could say this is my a and this is my b. The legs don't matter, the hypotenuse matters. I'm going to go back to what I had originally, just because I read from left to right. So I'm going to say 8 squared plus 15 squared is going to equal 17 squared. Oh, I was supposed to write, I did this in practice and I forgot what I was supposed to write where. So this is a squared plus b squared equals c squared. And this is where I'm going to plug in the numbers. 8 squared plus 15 squared equals 17 squared. Okay, 8 squared is 64. 15 squared is 225. And 17 squared is 289. So does 64 plus 225 equal 289? And yes, they are equal. It is a right triangle. Okay, so we have a couple more examples here. Is the triangle a right triangle? Go ahead and see if you can pause the video, do the work, and see if it's going to be a right triangle or not a right triangle. So do the first one and then come back and check your work, and then do the second one and then come back and check your work. Okay, I set up my work. A squared plus b squared equals c squared. I plugged in my numbers, checked to see if both sides of the equation were true. They were, so I know it's a right triangle. I could have said 8 squared plus 6 squared. This could have been my A, this could have been my B. They are interchangeable. It does not matter. What matters is that the longest side, the 10 feet, is my C side. Okay. Again, if you didn't already pause the video and do this one, go ahead and pause the video and then come back and check your work. Okay, so you just saw me plug in all my numbers and set this one up. It is not a right triangle, and um, the value of my legs squared is greater than the value of my hypotenuse squared, so it is not a right triangle. When the value of my legs squared is larger than the value of my hypotenuse squared, that means that this is an acute angle. This is less than 90 degrees. If it were the other way around, if my hypotenuse were greater, it would be an obtuse angle, meaning it was greater than 90 degrees. Okay, we are done with the lesson. So what I would like you to do before tomorrow's class, I would like you to do this exercise. I would like you to use a ruler to draw a rectangle to scale. What does that mean? You're going to draw a rectangle using a ruler. Let me see if I can insert a ruler here. Okay. Oh, come on. I just want to move you. There we go. And I'm going to have a side length of 7 meters and a side length of 10 meters. So I'm going to take a straight edge and, I'm sorry, centimeters, not meters, silly me. So here's my 10, and then I'm going to turn my ruler. And of course it doesn't want to turn now. There we go. And you can use the edge of your straight edge to help you to make the 90-degree angles. So this one I want to make, here I got to move this down more. This one I want to make 7 centimeters long. So I'm creating this rectangle. Okay. There we go. Then it says draw a diagonal through the rectangle. What does that mean? I'm going to go from one corner down to the other corner like that. So that's what it should look like. They want it to be drawn to scale, so side length of 7, bottom of 10, and then follow the rest of the directions. What 2 shapes do you have? Do you know all the lengths of the right triangle? What is the missing side, the A, the B, or the C side? Label the sides and show, just follow the rest of these directions. We will go over this first thing in class tomorrow. Have a good night. Bye.